All right, in the last video, we talked about tags and inputs and outputs and memory and data types of Boolean. And this video, we're going to be talking about starting to program. So on the left-hand side of the project tree up near the top, we have program blocks. So we're going to go ahead and click the little triangle there to expand that. Sometimes that will take a while, especially if this is the first thing you've done once you've opened your program or whatever. So don't be afraid if it takes it a moment or 30 seconds or whatever to like actually expand it. I can't tell you how many times I've tried to expand it, it not happened, I click it again, and then it actually collapses it. So you have to click it a third time to expand it again. But just something to be aware of. Underneath that program block section, we have main. It's labeled OB1. This is the code that is run when you start your PLC. And this is the code that will loop constantly as your PLC is running. So you do want to make sure that all of your code ends up in OB1 main. There are options to make other subroutines and things like that. We might talk about those at a later video, but for the purposes of this video, all we're going to do is here in the main. Now, over on the very right-hand side of your screen, you have all of the different instructions, as it says up here at the top. All right. You have your basic instructions, which is probably where you're going to spend most of the time, and it's probably going to be here in the bit logic instruction. So if we expand that, you can see all of the different types. Now, we're not using all those different types. So I wanted to point out that your instructions are over here, and there's a lot of them. You've got bit, you've got timer, counter, comparators, math, move, conversions, program control, word logic, shift and rotate. You know, there's a lot of different options over there. And then there's an extended option for doing more and more crazy things. For our purpose, though, we're actually really not going to be touching that. We're going to be looking at the favorite section, which up here is at the very top. Now, that favorite section, for those astute, you have already realized that it's not only there, but your favorites are also over here. All right, so everything that's in your favorite section there is over here. And if you'd want to add something to it, like you're like, hey, I really like the whole set reset, you can just drag a set reset to it. And boom, now you've got more stuff happening inside your favorites. All right. Now, for the purposes of keeping this consistent, I am going to remove those if I can figure out how to do that. I don't normally do that. Remove instruction, remove instruction. There we go. All right. So up at the top here, we have a few different ones, and I'm just going to put one of each in for right now. Well, actually, we'll just start. The first one is this, and if we hover over it, TIA calls it a normally open contact. All right. Now, this is one place that my students normally get confused. If you have a normally open contact, like a push button that's normally open, you don't necessarily have to use the normally open contact symbol. You could use the next one, which would be the normally closed. And the difference there is the little line between them. Now, students get confused when you're asking about a sensor or the contact in the program. So I have followed Big Bad Tech's YouTube channel, and I have started calling them make and breaks. So this symbol, the normally open one, I personally call a make, and I call it that in every piece of software. Alan Bradley, I believe, calls it like an examine if closed and an examine if open, and it's like, that is too much of a mouthful. So I'm just going with make and breaks, and that's what I follow. So the one over here on the left, this is the make. And the one to the right of that is the break. All right, so this one is true when you make contact. This one is true until you break contact. So yes, it's a little backwards is really what it comes down to. Another good way of thinking of this one is not. So it takes whatever the input is and does the opposite of it. So if you have a normally open contact, when it's open, it's not true, but it's now not true, so it's now true. So it's a double negative. So I often will call that a not too, but I'm working on calling that a break. So if you ever hear me use the term not, it's talking about the break symbol. Otherwise, make. So we can write some nice little code here. All right, so you can say a make, a break, and then the last one that you're going to use really often is going to be this. And this is just a coil output. So this is how you would actually turn an output on or off. All right, and if we call it, they call it an assignment. Again, oftentimes it's called a coil. I call it an output. And the reason that they can't call anything specific is because it could be a VFD you're controlling, it could be a contactor, it could be a relay, it could just be a light. Doesn't really matter what it is. It could be a lot of different things. So I just call it the output. But anyway, so if we go ahead and we put our start button here, where is my start? Oh, that's right, I called it button. So button, and then start, and then over here, I'm going to call the red question marks button stop. And then I'm going to saw this conveyor forward. And if you noticed, anywhere you saw those red question marks, that means you need to have information there. Another way that you will know that there's something wrong is you have an X up here in the top corner, all right, of the network name. So there's a little X there. If I delete this, the X goes away. But if there's something missing a tag or there's something wrong, it's going to put a little X there. This only goes so far. Now, another thing I do want to point out to you, so before we can download, you should really compile your code. And that is this little like double white card up here in the top corner. I don't know, not top white corner, but anyway, it's right there. If you hover over it, it does say compile. And if I hit that button right now, it's going to take my code, check all, see what's going on with it. And it is yelling at me. It's like, yo, jerk, you did something wrong. All right, so down here at the bottom, we can see we've got all sorts of red X's. Then it says PLC 1, that's a problem. Program blocks, main, network 1. So if we would look right here, boom, network 1. And then it says the operand required the input or output is missing or has, you know, it trails off there. But the really nice thing about this is I could be in memory, and if I click this little green arrow, it will take me right to that problem. All right, now if you have questions, you're like, what does this error actually mean? You can click on the question mark, and it will bring up a whole help window, which I will show you guys once it lets me move it. There we go. All right, it brings up a whole help window about what is going on. And it says, this message occurred for 2 reasons, and it's necessary an operand is not specified, or the specified operand has the wrong data type. So it tells you what's going on, and it will tell you that with every error. So the help here is pretty good, is really what it comes down to. But this little green arrow right there is like godsend, because you don't have to actually read all of this and go, okay, where is the problem? Network 1, and you're like, which is the problem? No, you can just click the little green arrow. Again, like I can even have this window closed. If you notice, it's not listed at the bottom anymore. Click the green window arrow. It takes us a little longer. Sends me right to the problem. So that is absolutely wonderful. Otherwise, if I compile this now, you'll see that it says all blue check marks, compiling completed, error 0, warning 0. If we had those tags overlapping with names, that's when that warnings would say 1, saying, yeah, we've got a little bit of a problem here. All right. So a little bit of a give and take going on there. Now, one thing that is very interesting to me is an input cannot be an output. That's not actually interesting at all. It makes sense, right? An input is an input. It's meant to bring information in. It's not meant to send information out. However, we can use an output as an input. So if I come up here and I click on this little down arrow, it's called open branch, all right? And then I put another make contact in, and I click the up arrow. It takes me there. Now, if I didn't want to use that up arrow, I want to cover both of these, I can click and drag, and it shows me the gray boxes where I can drop this. For my purpose, I want it around the start button. So I can put conveyor forward here again on an input symbol. It's on an output symbol. And now, anytime that the conveyor forward is true, this will also be true. And what you see on the screen right here is going to be used way too often in the world of PLCs. And actually, let me go ahead and just rewrite this ever so slightly. It's going to be the exact same thing, but just rewriting it slightly. All right, so we have stop button, start button, conveyor forward, what I call, as I call it, bypasses the start button. So as long as the stop button's not pressed, all right, power will flow through it. Once you press the green start button, power will flow through it, which will turn the conveyor forward on. The next time it reads this code, roughly a millisecond later, the stop button will still be true, but if you've let go of the start button, power can now flow down through the conveyor belt. So loop 1 of the code, power does this. It goes through these as long as that start button is pressed. But now, even if you were to let go of that start button, power would now flow this way because that conveyor is on. So even if the start button's not true, this is why I call it bypassing. It's like, oh, I can't get through that way. Can I go through a different way? And you bypass around it. So that is called a branch. All right. So that is, yeah, this is what I forget what I was saying, but this is what's called a latching circuit. So once the output turns on, the output will stay on even if you let go of a button until you press another button. So a little bit of weirdness going on there, but as you can see, even if the green button's not pressed, the output still is. So it's latched, it's turned on, and it's keeping itself on. So that is very useful for you through many, many different things. Now, the other weird thing here is we can do this slightly differently. So that's a latching circuit. There's also an output, which you're not going to see right off the bat. All right, if remember, I talked about set and reset. So you could come over here to your bit logic and find the set and the reset and then drag one of those in. So I could do this. We delete this one then. And it has a little S inside of it. So that is an output that's set. So that is actually a self-latching output. So as soon as this turns on, it comes true, it turns on, and it will stay on until the reset line is called. So down here, if I double click on this, you notice there's options. So we can actually drop down and say, oh, I want it to be a reset. You could do the same thing over here, but let me go ahead and put my buttons in first. Button stop. There we go. Hey, that was supposed to be down. So if you screw up, you put it in the wrong place, you can click and drag, and notice when it turns green, you let go, it moves it. If you hold control while you're doing that, it will copy it. All right. But anyway, we're going to copy conveyor down here into there as well. So these do exactly the same thing as up here. It's the exact same outcome for the most part. There's some weird issues when it might not work. But anyway, up at the top, if I were to press that stop button, remember the stop button's not pressed, start button is pressed, power flows right through. If I press the start button, power flows through. Either one would turn this output on. So once that output is on, and because this is a set and a reset, it will just stay on. So that will become green. All right. And up here, now after the first run, or loop 2, 3, 4, 5, whatever, power flows down here. Even if this isn't running, like we'd get to here and we'd stop, but because this is already on, it would stay on. Now, when you press that stop button, at that point, power only gets to here up here, and it would stop. So nothing past it, so that turns the output off. Down here, you press that stop button, it actually flows through it, hits the reset, which turns that output off, and you're doing them the exact same thing. So both of these work the same way in the long run. There is one weird thing that you have to remember about this, though, and that is if you're using a traditional output, like I have up here, traditional assignment, no set or reset, you may use that output name as an output one time in your code. All right. Down here, if you're using your set and your resets, you can use these as many times as you want in your code, and it will work just fine. So it is definitely something that you need to be aware of. If you're going to use an output, a traditional coil or assignment, you only can use it once in your entire code. If you need to have multiple things turn that conveyor on, you need to have multiple branches. So you would come down here and you'd branch another one, or you come down and branch again. All right? You'd have to have multiple branches or multiple bypasses to get that to turn on. Where the set and reset, you could just add multiple sets and resets to it. So this is a very, very handy thing to use, but it will get you in trouble every once in a while. So I personally really like using these, the traditional latching circuit in most instances. But every once in a while, those set and resets become very, very handy. So I wanted to talk to you about them. And that is all that I want to talk about in this one. So we've talked about make coils, break coils, make inputs, break inputs, or normally open, normally closed. We've talked about a coil assignment, and we've talked about set and reset. That's all I've got for this video. And at this point, you should be able to actually start writing code. You've got some tags created. You understand how to add things. The one thing I guess I will add here is this is one network. You can keep writing more and more networks. Let me get rid of all my text on the screen. Here we go. So you could have these all on their own network here. So you could bring them down here. I don't have a great answer for you. I like to divide things logically. So maybe this would be all of my outputs. And you can comment. So you have a comment section here where you can write whatever you want. And you also can put little comments here. So I might say real world outputs. And then this one would be maybe like stages, which is not what I've used it as, but that is how I've used it recently. And then down here, you'd be everything counter related. All right, so you put all your counters. And this just allows you to minimize these things, because again, imagine having 1,000 different networks. Well, if you had 1,000 different networks, look how much space this takes up, just with one line of code. It takes up almost twice as much. So by grouping things into your outputs and having your 16 outputs in one, you're saving yourself a lot of space. So I do like to use branches to organize all my outputs together, and then all my stages or counters or timers or things like that. That's a personal opinion. You could write all of your code in one single network. You could write one rung of code in every network. It's really how you like doing it, or how your company in the future wants you to do it. So that is important. Also, the comments are very important. It helps troubleshoot things. There's nothing worse than opening up someone's code that has 0 comments in it, and now you need to read through 1,000 rungs of code to figure out what is going on and then figure out what needs to change. So comments are extremely important, and I expect you to put them in there. But anyway, as I was saying, that's all I've got for this one. I hope that you do an okay job programming, and I will have more videos to come.